Hey, welcome to Tricksaw. In this video, we'll be discussing U-substitution, which is a necessity when solving for more complex integrals. Let's move on to our first practice problem. We have the integral of 3x squared times the square root of x cubed plus 1 dx. The way that U-substitution works is that we have to find an expression inside the integral and define it as u. Then we have to find the derivative of that expression and see if we can use it to cancel out the remaining expression. Let's choose x cubed plus 1 to be our u in this scenario. So u is equal to x cubed plus 1. Next, let's find the derivative of u. So du is equal to 3x squared dx. And the next step is to solve for dx so we can plug it back in to our original integral. Dx is equal to du over 3x squared. So now we can rewrite our integral. The integral of 3x squared times the square root of u, as we defined x cubed plus 1 to be u, du over 3x squared. And so as we can see, this worked, as now we can eliminate the 3x squared, which was our remaining term. Now we're left with the integral of the square root of u du. And just using the power rule, we know that this is equal to 2/3 u to the power 3 over 2 plus c. And the final step to get our final answer is to plug in u. And we know that u is x cubed plus 1. So our final answer is 2/3 x cubed plus 1 to the power of 3 over 2 plus c. And that's one example of how to do U-substitution. Let's move on to our next question. The integral of sine x cosine x dx. So again, let's define what u is. In this scenario, I'll say that u is the sine of x. So let's write that down. U is the sine of x, which means that du is equal to cosine of x dx. And solving for dx gives us du over the cosine of x. So now let's write our integral. The integral of u cosine of x du over cosine of x. Now we can cross out and cancel the cosine of x's, leaving us with a pretty simple integral of u du. And evaluating this integral gives us u squared over 2 plus c. And once again, our final step is to plug in u for our original expression, which was sine of x. So our final answer is sine squared x over 2 plus c. Let's move on to our last example. The integral of e to the power of x over 1 plus e to the power of 2x. So this one's a bit more complicated. First, let's rewrite our integral in a form that might help us a bit more. The integral of e to the power of x over 1 plus e to the power of x whole squared dx. So now I'm actually going to choose this term in the bottom right hand corner, just this e of x, to be our u. So let's write u is equal to e to the power of x. So du is equal to e to the x dx, which means that dx is equal to du over e to the power of x. So now let's rewrite our integral again. we have e to the power of x over 1 plus u squared du over e to the x. And now we can see we can get rid of the e to the x power, leaving us with the integral of 1 over 1 plus u squared du. And this is a bit harder to realize, but this is a very important trigonometric form. This is equal to the arctangent of u plus c. And once again, our final step is just plugging in u. So our final answer is the arctangent of e to the power of x plus c. And that's a wrap on U-substitution. In order to apply it, you still have to have a pretty basic understanding of integration. But as you can see, in many different scenarios, it is a necessity. Thank you for watching this video. If you have any questions or any other calculus concepts you'd like me to discuss, just leave a comment down below. Thank you for watching. I'll see you in the next video.